Hi guys, today what we're going to focus on is reviewing activity 32, so the stuff we talked about right before we left for break, which is all about area and circumference of a circle as well as the arc length and area of a sector. Now what we're going to need today is you're going to need a couple things: pencil, a calculator of some sort. You're going to need the note sheet that you either printed out or just a notebook that you could write these notes in, and your formula sheet if you have it. Now on the formula sheet, what you're going to notice is we are going to be focusing on these formulas right here: circumference, arc length, area of a sector, as well as the area of a circle, which is right here. Now, something to note when you're talking about your formula sheet, this measure here, this is called beta, and it's a Greek letter, and all it means in the case of our formula sheet is that means angle measure. It's going to be talking about an angle measure, which will hopefully make sense after we talk about the notes. Now, first thing on here you're going to notice is we're going to talk about the formulas just to kind of review. Now, circumference acts as basically the perimeter of a circle. It's the distance around our circle, and we have two different formulas for that, either pi times diameter or 2 times pi times your radius, right? Because 2 times your radius is your diameter. So remember that as well. 2 times the radius equals your diameter. Now, arc length, if you notice here in the picture provided for AB, is just a portion of your circumference. It's a fraction of it. Now, what fraction is it? Well, that's where that central angle measure over 360 degrees comes in, because that's going to be the fraction of the circumference. So 2 pi r, or pi times diameter, depending on what you're given. Now, area of a circle is pi times your radius squared. So if you're given the diameter, when we're talking about area, you have to convert it to the radius by dividing by 2 first. Now, the area of a sector is what I like to say the piece of pizza, all right, the piece of your pie. So notice we only want, again, a fraction of our circle's area. So where does that fraction come from? Again, we're going to take that angle measure over 360, and this time times the area. So again, notice the key words here of area in both of these. Now, also talking about that, for circumference and arc length, it's just going to be your units, right? Just units. For area of both the whole circle and just the sector, it is units squared as your part of your final answer. Now, when we talk about exact circumference or exact area, that is where they want us to write in using pi, but not rounding it, just leaving our answer with a pi. So, for example, if we are given that the diameter is 6 inches and we want the exact circumference, well, we know circumference is pi times diameter. So diameter 6 times pi. This is going to be the exact answer here. Notice we did not type pi to round into our calculator, and notice I used inches because it's circumference. It's not units squared, it's just inches. Same thing for the second one. This time they're giving us the radius, so we're going to want to use the 2 pi r formula, which means 2 times pi times our radius. Again, if we're leaving this as an exact answer, we're just going to leave the pi with the simplified numbers in front. Now, the next piece is going to ask us to work backwards. They want us to find the diameter or find the radius, but given the circumference. So this time, if we're looking for the diameter, again, circumference is pi times diameter. And we're given this time that C is 19 pi. And we're going to solve for that diameter. Well, as we solve, divide both sides by pi, you're going to notice that the diameter ends up equaling 19. And we don't have units on this. And for example, 4, when they talk about we're looking for the radius, we're going to use 2 pi r, since we're looking for a radius. And again, this time they gave us that the circumference is 22 pi. So we can solve divide by both sides by pi, and then divide both sides by 2, we get our radius to be 11. Well, moving on from there, when we are looking for the length of an arc, okay, the length of the arc, that's where we're going to use that arc length formula where we want angle measure divided by 360 times 2 pi r. So a fraction of the overall circumference. Now this time our angle measure is 24. So we're going to say, okay, 24 divided by 360 times 2 times pi times that radius they're giving us is going to give us our final answer. So we're going to type that into our calculator. 24 divided by 360 times 2 times pi. Make sure you use the pi button to get the most accurate answer. And then times that radius. It's approximately 2.09 if you round to the nearest hundredths, like they're telling us to in the given information. Now, reminder, arc length, like circumference, is not units squared, it's just units because it's at the perimeter. Be careful in example B, notice they're giving you the diameter is 9, which means the radius is going to be 4.5. Okay, so when we plug into our formula this time, arc length equals angle measure divided by 360 times 2 times pi times the radius. And type that in a calculator. So take a moment on your own, type into your calculator 56 divided by 360 times 2 times pi times 4.5. When you round to the nearest hundredth, you're going to want to be careful on this one because what's going to happen is hundredth is 2 decimal places. What you're going to notice is this is going to round up to 4.40 centimeters. Okay, so again, be very careful on that with your rounding. Last but not least, arc measure. Length of the arc. So again, we're using angle measure of 360 pi times diameter, round to the nearest hundredth. Again, you're going to want to be careful when it comes to your rounding here because angle measure divided by 360 times 2 times pi. Again, be careful here, your diameter is 14, so your radius is 7. So again, be very careful when you're looking at your given information and you type stuff in. You're going to get 8.79, but be careful that 6 makes the 9 round up, which is going to make the 7 round up so that your arc length actually equals 8.80 inches. All right, now moving on to the back side, we're going to start talking about area. And a reminder, the area of a circle is pi r squared. Okay, so you have to have a radius each time in order to find this. Now, as we start plugging things in, we're given the radius in example A that it's 9. So pi times 9 squared. The exact answer would be 81 pi. Or if you just round it to the nearest 10th, it would be approximately 254.5 centimeters squared because we're talking about area. So either of these, if they're not giving you specifications, would be acceptable answers on how to round or leaving it as an exact answer. Now, when they give you a diameter, again, you have to be very cautious to make sure for area you convert it to the radius. So you're going to need to divide the diameter in half so that you get 7.5 meters as your radius. Again, from here, you plug it into the pi r squared formula, and you're going to get either an exact answer of 56.25 pi, you just do 7.5 squared times pi, or you round, you're going to get 176.7 meters squared. Then as you type this into the calculator, just a reminder, make sure you are using that pi button to make sure you get the most accurate answer possible when doing this. Oops. Put that out. Squared. There we go. You see the answer there. All right. Now, like we worked backwards on the last page, this time they're giving us the area is 144 pi. And they want us to find the radius. Well, just like we solved before, we can plug in for a that 144 pi and now solve for our radius. So the pi's are going to cancel when we divide. And in order to get rid of the square of the r squared, we're going to have to square root. So the square root of 144 is 12. So that's the length of our radius is 12 feet. Well, in the second example, we're going to have to be careful because while this setup is going to be really similar, they're giving us the area. We now want the diameter. And a reminder, in order to solve for the area, we can really only use r. Okay, so what we're going to have to do is we're going to have to start this problem by solving for r first. Take the square root of 42.25, mind your square root button. Second, x squared 42.25. Oops. Our radius is 6.5. Now we have to be careful though, because always read the question. We want our final answer to be the diameter, so we're going to need to double that radius value to get our final answer for the diameter. Now, the next one's a word problem. So we have a circular pool, and we are given the diameter is 24. So we want to now find the area that the pool cover would need to cover the top of the pool. So again, whenever we're talking about area, it's important that we first find the radius so that we can plug into our formula pi times the radius squared. Again, 24 squared is not the same thing as 12 squared. Okay, 24 is not the same as 12 squared either. So we have 144 pi, which, if you type into your calculators, you should get approximately 452.4 square feet. Again, we weren't specific on our rounding, so you could either leave the answer as exact or round to the nearest tenth. Last couple examples then down here. We have the area of the sector. Okay, so again, area of the sector we talked about on the last page is the angle measure divided by 360 times the area, right? It's the fraction of the overall area. So we're only looking for the area of this piece right here. Right? So that's going to mean we're going to take that angle measure of 120 divided by 360, and we're going to multiply that pi times the radius squared. Now this one we're just going to approximate. So 120 divided by 360 times pi times that radius value of 15 squared. We get about 235.6 feet squared. And then in our second example, we have to be careful because notice they gave us the diameter. Again, the formula for area of a circle, area of a sector and a circle requires us to have that radius value. So while they gave us the diameter, we need to make sure we use the radius. And then the area of the sector is again going to be angle measure divided by 360 times pi times the radius squared. And type that in your calculators and approximate to the nearest 10. You should have gotten 22.6 centimeters squared. And again, area involves units squared. And our last example which many of you saw in the exit slip prior to leaving for break, is this lovely figure here. We want the total area of this composite figure. So we want to find the area of the composite figure, which means we're basically taking three different areas. The area of the triangle, the area of the quarter circle, notice the quarter circle, and then the area of the rectangle. Well, first and foremost, the area of this triangle is going to be 1/2 the base times the height of the triangle. Well, this is a right triangle, so the base and the height, notice here, base is 7 and height is going to be 7 of that triangle. So 1/2 of 7 times 7 is half of 49, or 24.5 square units. Okay, do not forget the 1/2 of this. Well, the next piece then is, let's look for the area of this rectangle. This rectangle has a base of 5 and a height of 9. So the area of the rectangle is going to be found by doing base times height, which is 5 times 9, or 45 units squared. Right. Last but not least, right, we want the area of this quarter circle. Now, in order to find the area of the quarter circle, let's start by thinking about the area of the circle. That's pi r squared. Now, what they're giving us in this picture, I'm going to just kind of draw this out to visualize a little better, is a quarter of the circle, which means the 7, that is not only the base of our triangle, but it's also going to be the radius of our circle. So pi r squared, well, we're going to take pi times that 7 squared. Now, we only want a quarter of the circle, though. So in order to only get a quarter of the circle, what we're going to do is take that final answer and divide it by 4. So we have 49 pi divided by 4, which is going to come out to be approximately, if we're rounding to the nearest hundredths, 38.48 degrees. Notice the nearest hundredths is where we're rounded. So last but not least, on this, we want the total area of this composite figure. So your total area is going to involve you then adding up all three pieces of this. The area of the triangle, the rectangle, and that quarter circle for a total area of 107.98 square units. All right, next hopefully we're working on some practice. And for this is a nice little review for you on the area and circumference of circles.